Okay, welcome to 7.1, solving one variable linear inequalities, part 1. Okay, so we're solving equations. We're going to solve one variable linear inequalities and graph the solution on a number line. Okay, so solving one variable inequalities, part 1. So this applies. So Frank has $500 in a savings account at the beginning of the summer. He wants at least 675 in account by the end of the summer. He deposits 25 each week. So write an inequality that represents Frank's situation. How many weeks does Frank need to deposit money into his account? And then justify your answer. Okay, so how many weeks does Frank need? So let's look at the information that we have, right? So Frank has $500 first. So 500 in savings. Let's write that out. He wants to have at least, right? He wants at least 675. Okay, he deposits $25 each week. Each week. Yes, when we look at these, so we always compare it to the y equals mx plus b, right? And we always look at what is the initial value, and then what is the rate of change. So looking at this situation, what is the initial value? Like how much money does he start with, right? So he starts with $500, right? $500 in savings. That's what he starts with, right? That's your initial value. So that's what he starts with. So we can put that in for B as our initial value. Okay, what else can we put in there? Rate of change. So which one's the rate of change? Wants at least $675 or deposits 25 each week, right? So this is the keyword each. Each week, right? Per hour. Those are all rate of change. Those are all changing. So $25 each week is going to be your rate of change, your slope. And that's the two things we need to make an equation, right? So we're going to write, so y is equal to our slope, our rate of change, which is 25, right? So 25x, and it has initial value 500, so positive 500. So he starts out at $500 and then $25 per week, $25 per week, okay? So he wants at least $675. And that's another keyword, at least. So how do you represent that? He doesn't want 679 exactly. He wants at least 675. So how do you write at least 675? Right? So we want our equation to be at least 675. Right? So we want it to be at least, so equal to or more, right? Equal to or greater. So that's going to be greater or equal to, right? And that is your at least. So that's how you get your at least. So at least 675, right? Greater or equal to 675, right? That's our equation that we start with, right? Our inequality, they call it, because it's not always equal. And now we can solve this. So we're just going to solve for x, right? Solve the regular way. So minus 500 to both sides. We get 25x. Bring this down, right? Greater or equal to, and it's 675 minus 500 is 175. Then we can divide by 25. And we get x is, and we're still bringing the same symbol down, greater or equal to 175 divided by 20. So $1.75 divided by 25 cents, right? How much quarters in $1.75? 7. So x is greater or equal to 7 weeks. Right? So how many weeks does Frank need to deposit money into his account? At least 7 weeks. right? So at least 7 weeks to reach $675. And that's his goal. So we just took our information that we had. 500 in savings, started out, that's our initial value. 25 each week, that's our rate of change. Write that into an equation with our slope and our y-intercept. And we just make it, we want it to be at least 675, so we make it greater or equal to 675. Right, and let's write that in there. So this is greater or equal to 675. Then we solve our equation. Minus 500 both sides, divide by 25. Keep our symbol, just bring it down. And we get x is greater or equal to 7 weeks. So at least 7 weeks to reach $675. Okay, so Uber money. An Uber driver charges $175 flat rate, in addition to 65 cents per mile. Katie has no more than $10 to spend on a ride, right? Then inequality representing the situation. And how many miles can Katie travel without exceeding her budget? Okay, so this again, let's write that down. So we got $1.75 flat rate. We're also given that 65 cents per mile. And wants to spend no more than $10. Right, so spend no more than $10 because that's all she has. Right, so those are 3 pieces of information that they give us. And again, we're going to compare it to y equals mx plus b, right, with our initial value and slope. So which one is our initial value? Right, what do you start off with? Right, flat rate. So whatever you start, you just start $1.75 automatic. Right, that's your initial value, your slope, or your y-intercept. And then your rate of change, right, this is your initial value. Then you have your rate of change, which is given 65 cents per mile, right? The per gives you the slope or your rate of change. Right there. Right, so that's our equation that we can write. We have y equal to our rate of change, which is 0.65 times x, and our initial value was $1.75. So it charges us $1.75 plus 65 cents per mile, right? And this is our equation, and we want to represent an inequality. So spend no more than $10. No more than $10. So 0.65x plus 1.75, and we want to say no more than $10. Okay, so up to $10. So how do you say less than $10, right? So less than or equal to $10, because no more than $10, including $10. So she can spend 10, right? So that's our inequality that we want to solve, right? So no more than $10 will give us that less than or equal to, right? So that's less than or equal to $10. And then we're going to solve this, right? So subtract 175 to both sides of our inequality. We have 0.65x. Remember, bring down that sign, same thing. And then $10 minus $1.75, it'll be 8/4. And then we're going to divide by our coefficient, right? 0.65 to both sides. And we have x is, bring this down again, less than or equal to, and 8.25 divided by 0.65 is 12.6923. What was your round it? So 12.69. Okay, so we want to go less than or equal to 12.69, and these are miles. So how far can she go? Less than or equal to 12.69 miles. We write that out. So less than or equal to 12.69 miles in order to stay under $10. Right, so again, write our information, given our initial value, put that in for B, given our rate of change, put that for M, set up our equation, and then we set it up our inequality is no more than 10, so less than or equal to 10, and then we just solve our inequality. Same way. So you guys can try the next two problems. Okay, so again, inequalities, right? So we have greater, right? Big side, small side. Always read left to right, left to right. So greater than, less than, greater or equal to with the line underneath, and less than or equal to with the line underneath. And remember, when we're solving, you must change the direction of the symbol whenever you multiply or divide by a negative number. That's important. Whenever you multiply or divide by a negative number, you have to change the direction of the symbol. And then also swapping left and right hand sides. Whenever you flip it, you have to also flip your inequality sign. Let's do a couple examples of that. So we have our inequality. I think this is our middle, right? You can write the line if it helps you. If not, you don't need it. So plus 7 to both sides is solving an equation. Same steps. We have 4x. Bring down this symbol, right? Greater than. Just bring it down. 17 plus 7, 24. Divide by a coefficient 4. And we get x is greater or equal to 6. All right, and bring down that symbol. So answer in set notation. So we're going to create a set, which is our brackets. All right, so bracket here. So x such that x is greater than 6. Okay, that is set notation. So we just put in x is greater than 6 right there. Okay, and the solution set represented on a number line. So greater than 6. So 6 can be anywhere, right? Just make this 0. 1, 2, 3, 4, 5, 6. So greater than 6 would be open circle. Greater than is to the right. Everything to the right. Okay, so open circle here. And then to the right is greater than. So you see to the right. Left way is less than. Okay, so next one. Same thing with this one, right? So subtract 36 to both sides. Get 2x and bring down our symbol. Less than 4 minus 36 is negative 32. Then divide by our coefficient 2. X is less than, right? Keep the same symbol. Negative 32 divided by 2, negative 16. And that's our answer. So set notation is going to be x such that, colon, x is less than negative 16. And our brackets. And then less than negative 16, we can make this negative 16. Open circle is going to be less than, and then less than is to the left. Right? So open circle is if it's not equal to. If it's equal to, then we're going to shade in the circle. Right? So this is greater than, less than, to the left. Okay? And then keep going. Okay, next one. Same thing. All right, so we want to get rid of our singles numbers first. So we're going to subtract 10 first to both sides. So bring down, remember this is negative 8x, so negative 8x less than 16. And then we're going to divide by a negative. Divide by negative 8 to get rid of that. So remember, when we divided by a negative, that was one of our things. If we multiply or divide by a negative, we have to change the direction of our symbol. Right? So if we divided by a negative, we're going to flip our symbol. So flip the symbol from greater than to less than. And that's negative 2. Right? So flip it because we divided by negative 8. So in set notation, it's going to be x such that x is less than negative 2. And less than negative 2, you make open circle, here's negative 2, less than, it's to the left, and we just shade. Okay, next one. Same thing, get rid of the singles first. We get the opposite of negative 1 is add 1 to both sides. Then we bring it down, so negative 6x less than or equal to 24. This one again, we're going to divide by a negative. Divide by a negative to both sides, we have to flip it. Right, so we have to flip our symbol from less than or equal to greater or equal to, and that's going to be negative 4. Right, so remember, we got to flip this because we divided by a negative. Okay, in our set notation, it's going to be x such that x is greater or equal to negative 4. And our number line, we can make this negative 4 and it's greater or equal to, so this is going to be closed circle. Greater than is to the right, yeah. Right, so closed circle because it's equal to, right, greater or equal to negative 4. Right, so always remember to flip. Whenever we divide by a negative or multiply by a negative to both sides, we have to flip it. Okay, let's do 9 and 10. A couple examples here. So this one looks different because your x is on the right, right? So we want to get it over to the left side to make it a little bit easier, okay? So we can start solving that and do it that way. But what we want to do is just take everything on the right and everything on the left and just swap it. Okay, so we're going to swap it or flip it. And since we're swapping that or flipping it, we also have to flip our symbol here. Okay, so we're going to write 3x plus 3 on the left, 42 on the right. We just flip it over. And we also have to flip our symbol from greater to less than. Okay, so we just flip it so the x is on the left. So that makes it a little bit easier. We can do minus 3, 3x less than 39, divide by positive 3 so we don't have to flip anything. X is less than 13. Right? And we write it in set notation, x such that x is less than 13. And we can make this 13, less than that is everything to the left. Shade it to the left. Okay, so same thing with number 10. We want to flip it. We want to take everything on the right, everything on the left, and we're just going to flip it. Okay, flip or swap, whatever word you want to use. So flip, and we also got to flip the middle symbol. Right, so we got negative 7x minus 2 and 26. We just flip those two. And in the middle, we just flip the sign from less than or equal to greater or equal to. Okay, now we can solve that. So we're going to add 2 to both sides. We have negative 7x greater or equal to 28. And then we divide by coefficient negative 7. Remember, when we divide by a negative, we have to flip our sign again. So x is now less than or equal to 20 divided by negative 7, negative 4. Right, so we have to flip this again. Right there. Right, so we have to flip it. So x is less than or equal to, that's right, function notation. So x such that x is less than or equal to -4. And then we start at -4, less than or equal to, so we make a solid closed circle, less than is to the left. So same steps as solving equations, only difference is we flip in our middle symbol here, our inequalities. Whenever we flip the inequalities. Whenever we divide by negative, we have to flip the inequality.